So in this video, we're going to look at a couple of system of differential equations that we actually can solve. We just in the last video we talked about what does the solution look like and how do you test whether the solution works or not. We're going to look at a couple of simple systems that we can solve. So to start off with a real simple one, dx dt is equal to negative 2x, and dy dt is equal to negative y. This is what is called completely decoupled. Because the dx equation involves only x and the dy equation involves only y. So we call that completely decoupled. So when they're completely decoupled, we can actually just solve the two equations separately and see what happens. So we could take this down here and say, okay, we got dx over x, this is of course separable, is equal to negative 2 dt, and that would give me natural log of x is equal to negative 2t plus c, and then that means that x is equal to k times c, we'll call it k sub 1, times e to the negative 2t. So that would be a solution to that first equation. Then likewise, if we go dy over y is equal to negative dt, that means that natural log is equal to, natural log of y is equal to negative t plus c, which means y is equal to, we'll do k sub 2 times e to the negative t. So that would be my two solutions, which means that means the solution to the system of equations would be that'd be equal to k sub 1 e to the negative 2t and k sub 2 e to the negative t. So that would be the general solution of that differential system of differential equations. And then let's say we get a given, let's say we're given an initial condition 1, 1. So we'd have to figure out, we can figure out what the K1 and K2 are, right? So, and this is my initial condition, we mean, I guess I should write that in there, that we're evaluating it at t. So that would be 1, evaluating t at 0. So that would be the point, that would produce the point 1, 1. So in other words, that means that x of 0, comma y of 0 is equal to 1, comma 1. So to find out, to solve this, we could say that 1 is equal to k sub 1 times e to negative, to the negative 2 times 0, which means 1 is equal to k sub 1. And likewise, we can take y sub 0, and that would mean that 1 is equal to k sub 2 times e to the negative 0. Of course, it's just 1. So once again, 1 is equal to k sub 2. So then my solution to that initial condition would be e to the, what did you say k was? Oh yeah, k is 1. E to the negative 2t, comma, e to the negative t. So that this would be this up here is the general solution to that different system of differential equations. This would be the solution to the given initial condition. Okay, so let's look at a different example. This is a partially decoupled, which means that one of the differential equations has only one of the variables and the other one involves both. So you can see in this one, dy dt is just involving y, but dx dt involves the x and the y. So this is called partially decoupled. If they're coupled, which means they're not partially decoupled or completely decoupled, if they're coupled, then many of those systems are impossible to solve. And we'll have to use some of the geometry techniques that we learned earlier. But in this case, we're going to be able to solve this one also. So first thing is you take the one that is independent, and we'll solve that. So you can do, dy over y is equal to -4 dt. And we've done this so many times we can do it in our sleep now, right? So that means that y is equal to e, oops, I need a k sub 1 e to the -4t. So that is a solution for the second equation in the system. And so that means, of course, that's the only one that'll work in that equation. So we need to, so in the other equation, y has to be equal to that. And so then we'll use that to find x. So this is kind of like the substitution method when we're just solving regular old systems equations, right? So then we're going to take dx dt, the equation is given to us, and that one has a 2x, which we'll leave as 2x. But instead of 3y, we're going to put 3 times, oops, I need to cross that out, 3 times k sub 1 times e to the -4t, because that's what we found out y has to be in terms of the other equation. Okay? Okay, so then now we're going to try to solve this equation for x. Now this is similar to some equations we've done before. This is a linear equation, right? But it's a not homogeneous linear equation. So because we have this other term here that doesn't involve an x. So we have a couple ways to solve that. One of them is the guess and check. So I'm going to try that on this one. Okay, so this is a linear equation that we can use the guess and check method with. And so first thing that we're going to do is solve for the homogeneous part. So, and we usually do like an x of h, if I don't guess. It's been a little while since we've done these. Well, not that long ago. And so let's see, that would end up being, we've done this quite a bit of time, so that would be k sub 2, because we already have a k sub 1 in it. K sub 2 times e to the 2t. In other words, remember what we're doing is we're just solving this equation as if there isn't the part not involving x, right? So that's the homogeneous solution. Then what we're going to do is guess for a particular solution for the whole equation. So that would be x sub p of t. And because it's involving e to the -4t, we're going to guess just an alpha e to the -4t. Then, of course, we plug in and see if it works. So we're going to hold this off for a minute. So if we plug that in, we get, of course, the derivative of that is -4 alpha e to the -4t minus 2 times that. It would be -2 alpha e to the -4t. And that's equal to 3 k sub 1 e to the -4t. Okay? Then we got to find out what alpha is. Let's see, -4 alpha and -2 alpha. That would be -6 alpha e to the -4t equal to 3 k sub 1 e to the -4t. And if I divide, well, if I just solve for alpha, I get alpha is equal to what? K sub 1 over 2. So then that's my particular solution is going to be k sub 1 over 2 times e to the -4t. Okay? So then we write our final solution, our general solution. That would be x of t is equal to my homogeneous solution, k sub 2 times e to the 2t plus my particular solution, That would be k sub 1 over 2 times e to the negative, whoops, yeah, negative 4t. Whoops, that should have been negative, shouldn't it? That should have been negative, which means that should have been negative. There we go. Remember, the solution to a different system of different equations is a x and a y value. That's my x and y function. That's my x function, and my y function was way up here somewhere. Oops, where was it? Oh, right there. K sub 1 times e to the negative 4t. K sub 1 times e to the negative 4t. And that was my y. Good. Awesome. So that would be my solution. Okay.